Okay, welcome to my talk titled 30,000 Frames Per Second nginx to Russia with Love. My name is Tracey Jaquith. My Twitter is @TraceyPoo. I'm one of the longest people from the Internet Archive. I started there in the 90s, if you can believe that. My title is TV Architect, and I work on video, audio, DevOps, and JavaScript, and of course, TV. The slides here are at tracy.dev.archive.org in case you want to follow along. That's tracy.dev.archive.org, easy to remember. So let's get right into it. What is server-side MP4 clipping? Well, it's basically taking an MP4 on the server backend and serving a smaller version of it, or a piece of it, losslessly on demand. And the way it does this is you parse and rewrite the moov atom, the header of the MP4. You rewrite some tables, do a couple different accounting changes and things like that, change the offsets to the AV packets, but you don't touch the AV packets, that's totally lossless, and you send out the smaller MP4 to the browser. Okay, why, Tracy? Great question. Why would you do server-side MP4 clipping in this day of HLS and Dash and all that? Well, we have lots of HD TV shows, so at, say, a 2 megabits per second 1 hour show, that's going to have about a 4 megabyte moov atom in the header. That's just all the metadata that points to all the audio, video, and things like that. So if you wanted to play, say, a 2 hour show, you're going to have to pull down 8 megabytes before you can really get started playing a first frame. There are a few clients that are advanced clients that are smart, but for the most part, they're going to have to download that entire header first. Whereas I can send out a 2-minute clip from the server side right to you with only 150K header. So let's talk about frames. There are different kinds of frames in video compression. They're all kind of pretty similar. There's iframes or keyframes, and you can think of those as like JPEG images, so they're full-size images, and they sort of look like you might imagine them to. There are predicted frames or P-frames, and those are smaller pieces that refer back to other iframes, or so that way to other iframes or to other P-frames. There's also bidirectional frames, and those can go both backwards in time and forwards in time. So they can go either way to pull in pieces of information to construct the entire video frame. So let's look at Happy Little Pac-Man here. So we've got Pac-Man on the top row is what you should be seeing out of your TV or monitor or whatever. And then on the bottom row, we see what are representations of the compression scheme. So the ends of the bottom row are keyframes. So there's 2 keyframes. And the next frame after the keyframe is a P frame. So it sort of says, hey, take those 3 dots from the prior frame and just pull them over. And that's all we really need to construct this frame. The next frame is a B frame. So that can pull a piece ahead of time, the little dot that's coming up, pull that in, and it can take that same little clip of 3 from before and pull it and move it a little bit closer. And that's all you need. This is another way of visualizing it. So M. Night Shyamalan in an interview or something like that. So if he's talking, maybe just his mouth or his eyes are moving, but you don't have to construct much of the background because it's not really changing. So that's another way to visualize how frames are stored. So here's some iframes and B frames and P frames, the last way to visualize it. So the P frame is going backwards in time to the iframe, and the B frames can go either direction. Generally, you don't go over the iframe boundaries unless you're maybe talking about HEVC with Blu-ray or something like that. But that's basically just how those little pieces go. Time is moving in that direction there. So, but there are some server clipping issues. So if you assume you maybe have keyframes like every 3 to 5 seconds, that's kind of typical. And you might have a 10-second max between keyframes. It's often with scene changes, but not always. But that means if you ask for an arbitrary start, you could wind up in a worst case scenario 9.9 seconds away from a keyframe that precedes where you want your start, which you need to show your frames. So yeah, the browser basically needs to see a keyframe before it can have all the information to construct a frame and put it up on your video. So let's roll the clip and show some examples. In this clip, it's about 14 seconds total. There are 2 people who are talking. There's keyframes at second 0, second 6, and 10.7 seconds. And their corresponding speed changes. So let's see what the first mod H.264 streaming from nginx module, which is a third-party drop-in. We'll talk about that later. So we're going backwards and forwards in time. So you say, I want you to start at 8 seconds in. But remember, there's only keyframes at 6 seconds and 10 seconds. So you want to jump right here. So what does this guy do? We're going to see what they do. So we'll hit play here.
She is giving voice, I think, to the kinds of principles that
Okay, so what happened? Well, they've dropped you in at 6 seconds, even though you asked for 8 seconds. So the video and audio stayed sync, but it was the wrong point of the clip. Let's look at the nginx MP4 module, which is the one that we're going to be talking about today. So again, you want start at 8, even though there's a keyframe at 6 and 10.7 seconds. So we go ahead and play that clip.
The kinds of principles that...
And you can see you don't even see the first scene. There's sort of garbage here. It doesn't really look right. It's ultimately the right audio, but it's not what you want video-wise. So I'm making a case that server-side MP4 lossless precise clipping is actually pretty hard, or seeking. Most of the time, just by the numbers, you're jumping in between keyframes, and that makes everything very challenging. So I had this idea some years ago. What if you begin, so this is your desired start point, find that keyframe before you, start there, start at this keyframe, but then those little frames in between, speed those frames per second up. So would that work? Could we do that? Let's just see what would happen. So with a patch that in fact does this, let's look at what happens. So again, asking for 8 seconds in between 6 and 10.7, and let's see the results.
I think the kinds of principles that...
So if you look really closely, I'll play it again. Obama's arm moves really quickly, and Angela's head moves quickly, a little surreally quickly, or supernaturally quickly. But that's because those first 2 frames are at 30,000 frames per second. And if you can see that, you have good eyes. Okay, Act 2, hacking. One of my favorite things to do. So let's hack some STTS and STSS move atoms. We're going to talk about those. And we're going to start back with a little bit of history first. In 2009, nginx was very young at version 0.8. We were using mod H.264 streaming 2.1, release Canada 2. And the only change I had to do was if you asked for an MP4 without a CGI arg of start or end, or you didn't have either, just return the clip as is, because some of our MP4s were having some problems with that model. And in 2011, they came out with mod H.264 streaming, another version, 2.27. That was great. That was probably the last version we were able to use. And in 2013, I came up with this idea of this exact start. So it will perceptually go through. You can see the original patch here, but we're going to talk about that in a second. So again, look for that closest keyframe at or before your desired start time. And the patch approach is take those audio samples and just throw them out. So just get rid of them and move up to where you want to be. Then take those video samples that are extra and make those all have a PTS value that's more than the frame after it. So each frame is going 1 PTS point further in time as opposed to 1,001 PTS points. We'll talk about that too. So let's get geeky with C. That was one of my first early programming languages. So here we're going to step through the STTS table and the entries. And we're going to go ahead and look to try to figure out where you actually want to start versus where the samples are. And we are going to, once we figure out where you want to start versus where the samples are in this little list, I can then adjust, like right here, I can adjust the PTS to a new value, and I can reset it back into the PTS array. The move atoms aren't really stored like that, but it takes care of it if you just set the PTS in this particular module. And then at the end, I write out some information just so you know how many frames move forward. In 2014, we got an exact end patch from Peter Vaja, who's a PhD at Stanford at the time, and that was great. Thank you, Peter. In 2017, one of the packets that was getting modified was having some kind of an issue, and I just had to make a little change there. In 2020, so last year, we switched all of our nginx servers to use a IP hiding module, a new library called IP scrub, which was exciting because it was out. And we switched everything to Ubuntu Focal while we were there, and we deployed this to all archive org nodes. That's my department compiling nginx. And that all worked out nicely, so that's great. In May of this year, there was some IP scrub improvements because we were hashing at a smaller number of buckets. So I increased the bucket size, working with a developer who found that at the org, and everything went out. And then 7 days later, after that new rebuild, which is pretty garden variety, the zombies came. So things started segfaulting. And on May 18th of this year, I wrote this commit message working around TV MP4 clips with the exact equals setting where we're having some sort of a segfault issue, and it was segfaulting almost everything. So if you look at one of our exact clips on the TV archive, you are segfaulting the nginx server for lots and lots of data, people. That was not good, super stressful, bad, bad, bad. FML. So I got 98% of the segfaults gone by completely taking over the memory management within this now abandonware. It's been long not been updated or maintained, and I even asked if they wanted me to take it over, and never got a reply. But there was still 2% of our clips that were segfaulting. So it was time to look at the MP4 module from nginx. So I went and looked through it with a fine-tooth comb, kind of comparing it in my head to what the other lossless clipper was doing, making sure it was lossless. But it's 3,500 lines in a single C file. I've been doing C code since I was about 18, 20. That is a very big file. I don't think I've ever seen that before. So yeah. However, it happens to be some of the best C code, maybe the best C code I've ever seen. Igor Siosev from nginx, who started nginx, wrote most of it. And then this other guy, Roman, who we'll talk about, is the next biggest committer, airtight stuff. So it reads top to bottom, it's beautiful, and I'm both intimidated and I'm exhilarated at the same time. This is a great place to be as a coder, I guess. So let me show you why I liked some of their C code. So here's an example. So we are looking at a STTS atom definition here. There's a bunch of stuff in there. It's relatively concise actually. It's concise like it's stored. So they don't add anything extra. It's just kind of like as it was stored and parsed briefly. Right after that struct definition, or that atom definition, is the read the atom definition as a function, which is really nice. So it's right there. Right after there is the update STTS atom, because we've got to update it and change some stuff around. And right after the update method is a crop method. And that crop method is going to cut to your start and end. And that's where we're going to be doing some additional changes. And you can see from that last method that that's where the start gets passed in. So that's where we're going to be doing some of the deep hacking. So I had already read the file top to bottom. It took about a day to make a plan of attack, if you will, and about a day to get the exact patch working. So that was great. I was very happy about that. So on June 1st, I wrote this commit that basically says we're moving from the abandonware module to this new MP4 server-side cutting module, and I'm going to try to get it upstream. That was the theory, this patch. So we've now moved from one MP4 server-side cutter to another server-side cutter with a hand-patched exact start. Act 3. Swimming upstream. I just swam 2 miles back east when I was on vacation, so woo. Okay, so atoms are the pieces, sub-pieces of the header, and it's wrapped inside of a larger thing called the moov atom, so atoms can be nested. And the two ones that are most interesting are STTS and SSTS. So this one is time to sample. So when you look at this table, you can figure out where every single sample or frame is because it lists the duration. So you know where the start time of each and end time implicitly of each frame. And then there's the STSS, which is the sync sample table. And that tells you where all the keyframes are within your MP4. There's some other tables we have to update, but the various MP4 cutters will take care of that for us. But this is just a comprehensive list so you can see them. This is a table from Apple. This shows a bunch of atoms and they're nested, and you can see the STTS and the STSS on the left side, and you can see some other atoms here. So again, that time to sample is list of frames and durations, technically speaking. And that's a table of 8 bytes where every single entry is 4 bytes for the number of frames that have this duration. So that sounds a little more complicated, which it is. But what that means is, in practice, is for a simple MP4, you generally have a single entry table where you have 4 bytes, which is the number of total frames in the video, and then just the duration of 1001, because most of the time that's what you're using. You might think, why 1001? Well, US TV comes in at 2997 frames per second. So that is 30,000, if that's your time scale, which it usually is in these tracks, divided by 1001. So that just shows you how much time to hold each frame, or a 30th of a second, roughly. So getting back to the atoms, we're going to parse the STSS list of keyframes. We're going to go that this is your wanted start. This is your first keyframe right before there. If you happen to land right on it, great, there's nothing to do. Otherwise, we're going to store that location. Now we know that there's this many frames between the first keyframe that's closest to you and where you want to start. And all we have to do now is move that count number of frames from 1001 to 1. And that goes from 30 frames per second to roughly 30,000 frames per second. So all we have to do is add one STTS new entry. We prepend it into that list, and it has the count of the number of frames, and it has the value 1. It's actually almost that simple. So then I had to figure out how to get it to nginx. Nginx has its own way of doing things, as do a lot of places, no shade there. But they're using Mercurial, so I had to figure out how to use Mercurial. Never used it before, so that's a little bit of a barrier for me, but that's fine. They also want you to patch your changes as opposed to committing them to any repo. You use something called patch bomb, and you send your patches to a private mailing list of developers that is moderated, and then they discuss and potentially approve and commit and all that. So it's a new world. It's a little different from GitHub or GitLab, which a lot of us are used to. I also had to figure out how to use sendmail with some configuration settings, which you can kind of see here. But yeah, it was a little complicated to figure out, and I had to write down some notes as to, I make this change, then I have to fish out this hash value, and then I've got to send it in with this email thing, which will then send it off to PatchBomb. So it's a thing. So I sent my patch to nginx on June 3rd, and I explain, this is me, so they don't think I'm an axe murderer, and show this is how your MP4 is doing clipping right now at the bottom there, and then this is what the proposed version would be with an exact cut, which is what I was calling it. And then I give some history as to like how long we've been using it and who the heck I am. So the first contact with the first guy on the list is like, well, why don't you just use a smart client and browser? I'm thinking, well, okay, well, I guess, but then why would I be using your module? I mean, I must be using it for some reason. So yes, there are smart clients out there, but not every client can do that. So I get a good point out of that, which unlocks me a level to Roman, who is the number 4 committer at nginx over time and the second most prolific committer in the MP4 module. It's mostly Igor and Roman, who are the big committers. So Roman's a wizard. We go back and forth. He points out some simplifications. I post a revised patch about a week or so later. That's 138 lines to do this exact cutting. He replies, I guess a couple weeks later, and said with his own revised patch, which I was a little surprised by, but that's okay. And his is 234 lines, where he also mentioned something like, hey, your patch title exceeds 67 characters. I'm like, okay. And he changes the name to rewind STTS data, which I guess that's fine. And then we now get the idea that this is going to be the MP4 seek frame config value. So that will be the thing in your nginx config that you'll be able to use, and has the commit marked based on a patch by Tracey Jaquith. Yay. He also mentions he didn't really test it. So I'm like, okay, I guess I'll test it. That's fine. So, but then I'm on vacation. This is where I'm half-time for 2 months, the longest vacation of my life. And I exercise 1 to 3 days. I lose 15 pounds. Take that, COVID. And feel great. Get back to work. And I test the patch heavily on Linux and Mac OS. Say it looks good. And I said, if I can't be a committer, because I was kind of hoping to be a committer, could we also credit the Internet Archive as well? And he writes back, yeah, basically based on the patch by Tracey Jaquith, Internet Archive, yay. On the 9th of this month, he says, we'll do an internal review of the patch now and then proceed to committing it. Okay, all right. Like the sound of that. And a few hours later, he said, we had a discussion here about enabling this feature by default or making it the only supported behavior. What do you think? What do I think? I think it's Snoopy Dance time. I am psyched. Maybe I don't get to be a committer formally, but I am getting my code, my idea, and refinements back and forth into one of the best or the best web server on the planet. So I'm psyched. If you are a nerdy accountant type like me, this next few slides are for you, and then we'll wrap up the talk. But this is dumping out the packets with ffprobe. So this is the current MP4 module and giving you a sense of like what's going on. So each row is a frame, and you can sort of see here that that's the PTS value. So they go up by 1001. That's the wall clock time of them each going up. And this is the position, just because it's kind of interesting as a nerd, the byte position where the packets are, and then that's the duration. And you can see here, this is the flag. So that's a keyframe down here. And the rest of these are all P frames. We don't tend to use B frames with our TV too much right now. So this is after the patch. So what's going on here? I'll point it out in a second, but you can sort of see the larger list here. So we've added 58 video frames to the front of that MP4 that goes out the server door. There are 57 keyframes that have been added after one keyframe. So that's our keyframe right here. So that's the keyframe that was originally 6 seconds in. So at 6 seconds in, that's where the keyframe is. But we now take those 58 frames, which is about 2 seconds, and we clamp the duration down to 1, so they fly out the door, and you can see the PTS time is just incrementally creeping up. So that's where you actually want to start. So that's the packet, that's the video that frame that went out before. It's still going out, but now its duration is still like it was. So all of these guys are mostly the same. Their PTS has incrementally gone up a little bit. And that's the original keyframe that you were seeing before. So again, new keyframe goes super fast. That's your perceptive start time. That's what you kind of see and feel. And we're done. Thanks so much for coming to my talk. Thank you, Demuxed, for hosting me and hosting everything and all these wonderful talks. And I'll see you later. Bye.